All right. Welcome again in another tutorial of the topic integration. So, in this tutorial, we're going to learn about moment of inertia. Now, consider the system of particles you see on your screen. So, we have this particle here. It's called, okay, there's no name. So, we have this particle here with mass m1. And then we have this particle here with mass m2. And then we have this particle here with mass m3. So let's say particle with mass m1 is located at a distance x1, and then particle with mass m2 is located at a distance x2 from the y-axis. And then particle with mass m3 is located at a distance x3 from the y-axis. So if I take the mass of this first particle times this x1, its position squared of its position from the y-axis, plus the mass of the second particle times square of its distance from the y-axis, plus the mass of the third particle times square of its distance from the y-axis, I get I. And this I now is what we call the moment of inertia. So I is also called the second moment. So remember in that tutorial called the center of mass, we learned about N. So N was the first moment, but I is the second moment. So now let's say now the total mass of this system is M. So let's say that total mass is M. Let's say that the total mass of the system is M, such that, okay, there was no need to put brackets here. I'm going to wrap them anyways. It's no big deal. So let's say the total mass of the system is M. So it means M is going to be equal to the mass of the first particle plus the mass of the second particle plus the mass of the third particle. Now, if the total mass of the system is concentrated at this point here, this one. So here is where the total mass of the system is concentrated, and this point is at a distance k from the y-axis. Therefore, if I'm going to take the total mass m times the square of that k, I'm going to get the moment of inertia. So this means that m times k squared is just going to be m1 times x1 squared plus m2 times x2 squared plus m3 times x3 squared. So this k now is called the radius of gyration. I'm going to pronounce it gyration. If I am wrong, I'm sorry. So it's called the radius of gyration. So now k, this radius of gyration, is just equal to I over m. The square of the radius of gyration is equal to I over m. So the radius of gyration is just going to be the square root of I over m. So this is I is the moment of inertia. That's about the moment of inertia. Now this was for a system of particles. Kwa hiyo kama vile sasa kwenye center of mass derive formula ya center of mass kwenye system of particles, alafu baadaye kidogo derive formula ya center of mass kwenye continuous body. Na hapa pia I want to derive the moment of inertia for a continuous body. So I mean continuous body ni kama hii fimbo hapa chini. So let a rod of length L be situated along the x-axis. Kwa you can see hapa kuna fimbo chini with one end at the origin, imeanzia hapa alafu imeishia hapa at distance L from the y-axis. So and then we have rho, it's called the line density. So I already defined the line density kwenye ile tutorial ya center of mass. So angalia tutorial ya center of mass. Sasa kwenye system of particles tulikuwa na zile particle. Lakini kwenye continuous body hatuna particle, tuna body moja tu. So what we are going to do, we are going to consider an element of a body. Maana yake kipande cha body. So I'm going to consider this is called the element of a body. So this element of a body is located at distance x from the x-axis, from the y-axis. Let me repeat that. This element of a body is located at distance x from the y-axis. Mwanzo wake ni from distance x, afu mwisho wake ni x plus delta x. Manake, so hapa ndo hiyo x plus delta x, hapa ni x. Manake urefu wa hii body sasa, wa hii element sio urefu wa body, urefu wa kipande wa hii element ni delta x, kwa sababu nitachukua hii x plus delta x minus x. Kwa hiyo the length of the element ni nani? Ni delta x. Sasa let delta m iwe ni mass of the element. Manake nini sasa? Manake ni kwamba remember line density tulisema ni mass per unit distance. Manake sasa rho, yani line density of the element itakuwa sasa na mass ya element chini ya length ya element, like that. So remember hii line density, by the way, it varies with x. So line density ya hapa, kwa mfano hapa ninapo pachorachora sio sana line density ya hapa. So hii line density ambayo sasa delta m over delta x ni line density ya hiki kipande ya hiki kipande hapo. So the line density now of the element, this one is the line density of the element, ni sasa na delta m over delta x. Manake sasa if I cross and multiply, I'll get the mass of the element. Itakuwa sasa na line density times delta x. So this is just the mass of the element. But since tunataka the mass m, mass of the whole continuous body. Kwa hiyo mass of the whole continuous body manake nitakuwa na element kama hicho nilichokuwa nacho hapa. Nitakuwa na element vingi kuanzia mwanzo mpaka mwisho. Alafu nitajumlisha mass ya hivyo element, ndo nitapata mass of the whole body. So kumbe mass of the whole body is just summation of the mass of the element. Lakini mass of the element tumesema ni elements, so size zinakuwa nyingi hivi. Sasa for accuracy tuwe na element vidogo vidogo, manake delta x iwe very small approaching 0, ndo tutafaana. Manake sasa the sum we get is gonna be a limit of a sum as delta x approach 0. So now the mass of the whole body, kama nilivyosema hapo, ni the limit of this summation here as delta x approach 0. But remember tusema integration is the limit of a sum. Kwa hiyo manake itakuwa ni we integrate rho afi delta x sasa inakuwa nini? Dx. Sasa continuous body yetu imeanzia wapi? Imeanzia at the origin at x equals to 0 mpaka at distance L from the y-axis at x equals to L. So this summation is from 0 to L. So this is the mass of the whole body. Lakini sisi tunatafuta the moment of inertia I of the whole body. Naomba niandike tena hapa mass, you integrate from 0 to L rho dx. Sasa sisi tunatafuta nini? I. Sasa let delta I be the moment of inertia of the element, ile element yetu ile ambayo ina urefu wa delta x. Then delta I over delta x itakuwa ni sawa na nini? So kwa particle sawa, inertia ya particle moja unachukua mass yake times distance squared. Sasa manake kwa ile element itachukua mass of the element, tunaikumbuka delta m times distance. So the element is located at distance x from the y-axis. Kwa hiyo distance ni x, kwa hiyo times distance squared. So unaweza ukaniuliza sasa, mbona nimetumia x and not x plus delta x? This is because tushasema delta x na approach 0, manake ni ndogo sana, iongezi kitu, manake x jumlisha delta x ambayo ni almost 0 is just approximately equal to x. Okay, delta x is very small compared to x. Ndio maana hapa tumeconsider x. Kwa hiyo moment of inertia ni x squared times the mass over, usawi huku, delta x. So delta m over delta x ni nini? Line density. Kwa hiyo itakuwa ni x squared rho. So I want to write again the mass of the whole body. Just like writing it everywhere. So tumeona kumbe moment of inertia ya kile ki element chini ya length ya kile ki element ni sawa na x squared rho. Kwa hiyo moment of inertia ya kile ki element ni sawa na x squared rho delta x, lakini sisi tunatafuta I. Hii ni moment of inertia ya ki element. Sisi tunatafuta I ambayo ni moment of inertia of the whole body. Alright. Sasa ili kupata moment of inertia of the whole body itabidi niwe na element vingi afu nijumlishe moment of inertia yake. Tunakumbuka hata kwenye system of particles I ilikuwa ni m1 x1 squared plus m2 x2. Kwa hiyo na hapa I nitajumlisha delta I ya kila element, lakini delta I niseme nitajumlisha delta I ya kila element, lakini element vyangu nataka viwe vidogo as delta x approaches 0, so my sum is the limit of a sum. Lakini delta I ni nani? Ni huyu hapa, so I is gonna be the limit as delta x approach 0 summation ya x squared rho delta x. But integration now is the limit of a sum. Kwa hiyo I itakuwa ni sawa na uintegrate x squared times rho, so hii delta tunatoa tunaweka d, so it's from 0 to L. Kwa hiyo hii ndo nini? Moment of inertia of the what? Of the continuous body. So I'm afraid you will have to remember that formula, or at least understand this derivation so well to remember it always, because you are going to use it to solve questions. Okay, so that's the moment of inertia. Unakumbuka radius of gyration, eh? So radius of gyration tulisema sasa I over m. Kwa hiyo kwa continuous body itakuwa ni nini? Wana mimi nimekumbuka, sio nimeshafuta, lakini naikumbuka I over 0L rho dx. So I over m ni radius of gyration squared. Now let's solve example. Just one example. And so I call this example 1. Nasema find the moment of inertia of a rod. We'll have only one example, don't worry about your bundle. Okay, find the moment of inertia of a rod in which the line density varies as the square of the distance from one end. So sisi tuna rod kama hii. Distance from one end ni nini? Ni x. So anasema find I of this rod if the line density rho varies as the square of the distance from one end. Distance from one end ni x, kwa hiyo it varies as x squared. Kwa hiyo kumbe line density itakuwa ni sasa na nini? K x squared, where k is what? Kwenye ile topic ya mathematics tulikuwa tunaita k, ile topic ya form 3 ya roots and variation, tulikuwa tunaita k ni constant proportionality. K. Kwa hiyo ni to find the moment of inertia. Sasa formula naijua. Moment of inertia tumesema ni sasa na nini? Integrate from 0 to L, chukua rho x squared dx. So tafute basi moment of inertia. Kwa hiyo tushaona moment of inertia ni sasa na uintegrate from 0 to L. L ni urefu wa rod. L is length of rod. So line density x squared dx. But tushaona line density ni nini? Kx squared. K is constant. Kwa hiyo I itakuwa sasa na from 0 to L. So line density sasa ni kx squared times x squared dx. So tuanje K, moment of inertia itakuwa ni x power 4 dx. So nikiintegrate x power 4 napata nini? Napata x power 5 over 5 from 0 to L. 5 is constant, itoe nje pia. It's just k over 5 x power 5 from 0 to L. Kwa hiyo I itakuwa sasa na k over 5. So we're gonna have L power 5 minus 0 power 5. So I now is gonna be equal to k over 5 L power 5. Sasa hili jibu langu hili sio jibu langu la mwisho, because K inabidi ni eliminate K. Hawezi weka jibu lenye K. So ni eliminate K. I nimepata sasa na K over 5 L power 5 Ili ku eliminate K nitafute mass. Sasa mass formula yake tulisema ni integrate from 0 to L rho dx. But rho tumeshaona kwenye swali letu ni kx squared. Kwa hiyo mass itakuwa sasa na integrate from 0 to L kx squared dx. So toa k nje is constant, tunabaki na k integrate from 0 to L. So when you integrate x squared, you get k power 3 over 3 from 0 to L. 23 now. It's going to be k over 3. So x cubed from 0 to L. Kwa hiyo mass itakuwa sasa na k over 3. So we're going to have L cube minus 0 cube. Kwa hiyo mass now itakuwa sasa na k over 3 L cube. Kwa hiyo kumbe nikicross and multiply hapa 3m sasa na nini? KL cube. Sasa turudi kwenye ile moment of inertia yetu ile. Moment of inertia tumepata ni k over 5 L power 5. Kwa hiyo sasa na mtu aseme L squared over 5 times KL cube. Lakini tumeona kwamba KL cube ni sasa na nini? 3 times the mass of the whole body. Kwa hiyo kumbe finally the moment of inertia is going to be equal to, so hapa kwenye KL cube naweka 3m L squared. Sasa hii ndio moment of inertia. Hii ndio jibu langu la mwisho. So let me say now, see you in the next tutorial.